So hi, in the last lecture we solved largest rectangle with order of n time, but over there we used two extra array, left array and right array that takes order of n space. What if I told you that we can eliminate both arrays and solve this problem just using one stack? Same order of n time, but now order of n space becomes just the stack. So let me show you how. Now I'm taking the same example. Okay, let me convert it into the histogram. Now we will be finding the next smaller element and the previous element on the fly. Okay, so I will be iterating, or I will be traversing from left towards right. Now see guys, since I'm traversing from left to right, okay, for this element I do know that what will be the previous smaller element, which is this, since I'm traversing on the left. Okay, so this is one advantage, but how can I find the next smaller element with this approach? Let's see. Over here, let me create this stack. Okay, so I believe that you have watched my previous lectures. Okay, if you haven't, I would be highly recommending you to please watch, otherwise you will be not understanding this approach. Now when I'm standing over here, I do know that the previous smaller element is this, and this element will be basically stored inside this stack. And also the second point is that if when I'm standing over here and if the 5 is present inside the stack, 5 is of no use. Why? Because this 5 can never be the answer for the remaining elements. So if that's the case, then I need to pop this 5. Okay, similarly, if imagine that 5 4 5 is present into the stack, and if I'm standing over here, this one can be the answer for this remaining element. 5 4 2 cannot be the answer, so basically I need to remove this 3 elements. Okay, now I have just given you the overview of the previous lectures. Now let's start. Right now I'm standing at index 0, in which the element is 6, and the stack is empty. Okay, since I need to find the width, so I will be storing the index rather than value. So 0, and over here for our purpose I am having 6. Okay, let me give you the area as well. Area is equals to height into width, and the formula for width is p2 minus p1 minus 1. Okay, now we are standing at index 1. Over here the value is 2. So see guys, if 2 is there in the middle, 6 can never be the answer. Okay, but see, since I need to pop the 6, okay, why I'm popping? Because I do get the next smaller element. Okay, so first pop the element from the stack. Okay, and whatever you have popped at index 0, height was 6. Okay, where I'm standing at index 1, so this will be my p2 minus. Over here I do see that the stack is empty. If the stack is empty, the p1 will be minus 1. Okay, if I calculate this, 6 into 1, so the answer is 6. So for this, if I want to include this in the rectangle, the area will be just this one. Okay, so this area is 6. So right now I do get the area which is 6. Okay, now if I get any area which is maximum than the current one, then I'll basically update it. Okay, and don't forget, for every operation you need to store the indexes of that value. So 1, the value is 2. Okay, now I don't have any next smaller element for this. Okay, so I'll just simply move forward. Now I'm pointing at index 2, in which the value is 5 and the index is 2. Over here also I don't see any smaller element, so I'll move forward, in which I'm pointing at index 3. Now over here I do see that if 4 is there, 5 cannot be the answer, right? So I need to pop this element. Okay, the index 2. Okay, why I'm popping this? Because I do get this next smaller element. Okay, and where would be the previous smaller element will be stored? Just at the top of the stack. Okay, which is 2. So the element that you popped is index 2. In index 2, 5 was there, so 5 into where p2 is there, 3, that is where I am pointing right now, that is 3, minus where is the previous smaller element is present at index 1. Okay, so I'll have 1 over here minus 1. So 5 into 1. So answer is 5, which is not beating this 6. So over here you can see that this is the rectangle. Okay, after this I need to store index 3. Over here the value is 4. Now let's move forward, in which I am pointing at index 4 now. So for this element I don't see any next smaller element, so I'll simply store that value. So index 4 and the value is 5. Now I'm pointing at index 5, in which the value is 1. Now see, if this is present, right, 5 cannot be the answer, right? So I'll basically pop this. That means the index 4. And index 4, the element 5 is present. So 5 into where I'm pointing at index 5 minus where is the previous smaller element is present over here, that is 3. So I'll write 3 over here minus 1. So this will give me 5 into 1, that is 5. So over here also you can see that this is the rectangle. Okay, now right now also I'm pointing at index 5 only, in which the value is 1. But if 1 is present, 4 cannot be the answer, right, which is present at index 3. So I need to pop this. So I'll take that value, which is 4, into where I'm pointing now, 5, minus what is the previous smaller element, which is present at index 2. So you can see that for 4, the previous smaller element is 2. So 1, 2 is present at index 1, minus 1. So 4 into 3, the answer is 12. Over here you can see that if I want to include 4 in the rectangle, the area will be 4 into 3. The width is 3. Okay, so I got the highest area till this point. So I'll update it to 12 now. Okay, again, if 1 is present, 2 cannot be the answer. So I need to pop this as well. So I'll first pop it 1. In the index 1, 2 was present. So 2 into where I am pointing right now, 5, minus. See guys, over here I do see that the stack is empty. So the P1 will be minus 1. Minus 1. So 2 into 5, it will be 10. So over here you can see that if I want to include this, the width will be 5. In which 2 into 5, the area is 10. Okay, but it is not beating 12. So I'll not update it. And after this, I need to push index 5. Over here, the value is 1. I believe that you are getting it. Now let's continue. Now I'm pointing at index 6. Over here, the value is 6. And I don't see any next smaller element. So I'll simply push it. Index 6, the value is also 6. Now I'm pointing at index 7, in which the value is 3. Now see, if 3 is present, 6 cannot be the answer. So basically I need to pop this 6. Okay, when I'm popping it, I need to take that value. At index 6, 6 is present. Need to multiply with P2 minus P1 minus 1. So P2 is nothing but where I'm pointing right now, which is 7, minus where is the P1 at the top of the stack, which is 5. Minus 1. So if I solve this, 6 into 1, the answer is 6. So if I want to include 6, this is the rectangle. Okay, now don't forget to add this index 7. Okay, now guys, why I'm not popping this 5? Because over here I do see that 1 is basically lesser than 3. Okay, hence I'm not popping it. Now I'm pointing at index 8. Over here the value is 4. Now I don't see any next smaller element. I'll basically push it into the stack. So index 8, over here the value is 2. I'll move forward. Now I'm pointing at index 9. Over here the value is 2. If the value is 2, this cannot be the answer. Nor this, right? I need to pop it one by one at a time. So I'll pop this first, in which the value present at index 8 is 4. So 4 into where I'm pointing right now at index 9 minus where is the previous smallest element present over here at index 7. So you can see that for this is the previous smaller element, minus 1. So if I solve this, 4 into 1, the answer is 4. So here you can see that this is the rectangle, right? Now, since this is not beating 12, so I'll not update it. Now, if this is there, 3 cannot be the answer, right? So again, I need to pop this as well. I popped 7, in which at 7, 3 was present. So 3 into where I'm pointing right now, 9 minus what is the previous smallest element which is present at index 5. So here you can see that for this 3, the previous smallest element is present at index 5 minus 1. So 3 into 3, the answer is 9. So you can see that if I want to include this height as 3, this is the width, which is 3. But this is not beating 12, so I'll not update it. Now after this, I need to push this index 9. Over here, the value is 2. Okay, and I'll move forward. Over here, I need to terminate that loop. Now see for which block I have calculated the value. For this, for this, for this, 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 this. And for index 5 and index 9, I didn't calculated the area. Why? You can see that for these elements or for these blocks, there is no next smaller element present, right, on the right hand side. Okay, hence this were not able to pop it. So since you need to find the area as well for this and for this as well, okay, so what you can do, you can just have one more loop in which the boundary for the P2 will be nothing but 10. Okay, will be nothing but 10 because this will be the last boundary, right? So you can just have one more for loop in which one by one you will be start popping this element. Okay, since right now you are popping the index 9, at index 9 2 is present, so I'll write 2 into this will be 10. Why 10? Because the boundary is this. Okay, basically you need to write the length over here minus where is the previous smallest element present over here at index 5. So I'll write 5 over here minus 1. So this will give me 8. Okay, over here you can see that if I want to include this, the width will be 4. So 4 into 2, it will be 8. Hence I got this. Now still one element is remaining, so I'll pop this as well, and one I'll write it. The P2 will be same, that is 10, that is nothing but the length of an array, minus what is P1, that means what is previous smaller element. Over here I don't see any smaller element, right? So I'll just simply put minus 1 over here, minus 1, and if I solve this, I will be getting 1 into 10, which is nothing but 10. So if I want to include this, I can see that the width will be nothing but 10. Okay, and hence I got this. So basically in this way we can solve this approach. So I have just taken the help of stack, nothing left array nor right array. Okay, now let's talk about the pseudocode for this. According to the LeetCode, the function name is largest rectangle area, in which they are passing array by the name height with s. Okay, now I will be calculating the length, so height dot length, and then let me create the stack in Java. Now over here I have created this stack. I'll also initialize the max array to find the maximum array, in which it will be 0, and the area to find the area of for every block. Now I will be having a for loop in which I will be running from 0 and it will be gone till n, because we are finding the area for each and every block. right? So hence the for loop will be running from 0 to n. Now if any current block is having height lesser than the top of the stack, over there I need to pop it. So I will be having while first I'll check if my stack is empty or not. If it is not, then only I will do that operation. So height of stack dot peak. First I'll check if that element is basically greater than the height, current height. That means height of I. So instead of calculating heights of I again and again, basically I'll just calculate it at the top. So int val is equals to height of I. And I'll just simply put val over here. If that's the case, then basically I need to pop that element and I need to find the area. So int height is equals to heights dot stack dot pop. So since we are storing the index, okay, not the value, so hence I am writing in this way. Now I got the height. Now I'll check if stack dot size, if it is equals to 0, that means the stack is empty. And if the stack is empty, my P1 will be -1. So now I'm calculating the area, which is height, which is this, into P2. What is P2? Where I'm pointing right now, which is I minus C minus P1, right? But over here the stack is empty, so I'll write -1 -1. Okay. Otherwise, if the stack is not empty, then the area will be height into I minus stack dot peak, because the previous smaller element is present at the index of stack dot peak. Okay. Now if area is maximum than the max area, then we need to update it. So max area, I'll check max area is equals to max of area comma max area. If that's the case, then I'll basically update it, and that's it for the while loop. Now after every operation, basically I need to update, or I need to push that value or push that index into the stack. So stack dot push of I, and that's it for the for loop. Now there will be a case that the stack is not empty. Okay, so you need to pop that element one by one and you need to find out the area. So let me write it over here. While first I'll check stack of size if it is greater than 0. Okay, then I need to calculate the height. So height is equals to heights stack dot pop. So since I'm storing the indexes, not the value, so stack dot pop will give me the index and this will give me the height of the current block. Now I need to calculate the area and I need to apply the same thing over here with one change that I'll tell you. If the stack is empty, then the P1 will be -1, right? But guys, see here, this while loop is for when I have terminated this for loop. Okay, so the P2 will be nothing but the length of an array. So I need to write len. Okay, over here also I need to write len. That means the length of an array. Okay, and that's it. Only these changes you need to make and you're done. And at last you need to return the max area. And that's it, we are done. So this seems very complicated, okay, but if you dry run it for 2 to 3 times, okay, you will be getting a grip that how it is working. Now talking about the code performance of this approach, the time complexity is order of n, and the space complexity is also order of n. Okay, the previous approach was also taking this time complexity only, but over there we were using two arrays, the left array and the right array. And in this approach we have find out the previous smaller element and the next smaller element without taking the help of any arrays, that is on the fly. Okay, so that was the specialty of this approach. So I believe you got this. If you didn't, please try run it by yourself as well. So that's it from my side. I'll see you in the next lecture. Till then, keep practicing. Thank you.